right, so section 2.4, part 3, the last part, we're going to do all, did I say it already? Do we know how many trig functions there are? 6, okay? The only ones you're going to have to remember are the ones we've talked about. So the derivative of sine is cosine. And then the derivative of cosine is, did I say it? Do you remember? Negative sine. Now these other 4, you're just going to have to look them up. I'll give them to you on the test. So the derivative of tangent is secant squared. And then, we'll put up here, the derivative of secant is secant tangent. And then the last 2, the derivative of cotangent. Tangent was secant squared. Cotangent is negative cosecant squared. And then the very last one is cosecant. And just like secant then was secant tangent, cosecant is negative. This one is negative as well. Negative cosecant cotangent. For Weathersine, if you have to type in a squared, and maybe it's just good to know too. We'll do secant. Secant squared is the same thing as secant and then squared. Okay, those mean the same thing, and you can type them in either way on Weathersine. At first, I thought we had to do this, but if you go back and just put an exponent in, Weathersine will take it that way too. You just got to go back right after secant and make that an exponent, and that'll be okay. I think the only thing is I think Weathersine forces these parentheses, so it would look like that.
Does that prevent the square from applying to the x in the second one? It looks like you wouldn't square the x in the first one.
So for both of them, that's a good question. For both of them, we're not squaring the x here, and we're actually not just squaring the x here. We're squaring secant of x.
So x doesn't technically get squared.
Right. X does not get squared. Right. You would figure out, let's say secant was pi. Okay, or it could even be a number. You could even just think of it as 4. You would do secant of 4 and then square that answer. Yeah, so this would be secant of 4 and then you would square that answer. So yeah, that's a good point. In both of those, we're not squaring the x. Very good point. The only reason in math we like to write the squared here is because then see how we have to use one less parenthesis. We're all about minimalizing in math, right? Or we're just lazy, either one. We don't want to write any more than we have to. But you can type it in either way on your calculator or on Weathersine. Okay, so let's put into play all our rules, our product rule and our quotient rule with trig. We did some already with sine and cosine for product rule, but let's differentiate or find a derivative, whichever one. Let's see. We'll do find the derivative. Forget which one is on the homework. Before we get into it, let's talk about this one real quick. We'll compare these two. So let's take a look at y equals 5 plus sine of x. we'll ease our way into it, but I want to compare this to one other thing because we kind of messed this one up. Here we've got two terms. So we're going to do the derivative of this guy and then the derivative of this guy. Okay. So the derivative, or are we okay with that? Do we see how there's two things there, two terms? All right, so the derivative of 5 is 0, so that guy goes away. And then the derivative of sine is cosine. The reverse, the derivative of cosine is -5. So lucky my sister's name is Sherry Colleen. So if it goes S to C, then there's no negative. If it goes C to S, then I know it's backwards, so I put in my negative. I'll remember my sister Sherry Colleen. She doesn't like her middle name, but I love it. All right, okay, so now let's compare that to this one. Y equals 5 sine of x. 5 is just a coefficient, and coefficients just hang around. In fact, let's put this up here. Y equals, let's even do 3x to the 4th. We're actually pretty good. We know we're like, oh, that's 12x to the 3rd. But let's think about this. Really what the 3 is doing is just tagging along as multiplication, and then I do 4x to the 3rd. Okay, so think of the coefficient as just tagging along as multiplication. So on this problem, same thing. 5 is a coefficient, it's just tagging along as multiplication. And so I really just have to do the derivative of sine, which is cosine. And for some reason, when there's a coefficient with the trig, we want to do something with it, or we want to take its derivative. It just tags along. It's still considered a coefficient, and it just tags along. Okay. Here, the only thing is here we can actually multiply this stuff, and here we can't. So we just write it as 5 cosine. All right, let's try. Let's try y. I'm just gonna mark this as a derivative, right? Even back here, let's mark this, guys. Let's make sure that it's so excited about finding it. Well, we got to mark it correctly. Mark that as a derivative. Okay, that's fine. Okay, y equals cosine of x plus 4 cosecant of x. So kind of like that first one, we were going to do the terms. We've got this term, and then we got this term. Okay. We got two terms. We're just going to go through it. All right, derivative of cosine, negative sine. And that's it. We did that first term. Now we do that second term, and there's that 4 floating around. That's just going to come down. The derivative of cosecant is, yeah, perfect. Yep, negative. So don't just put a minus, it's times, because we talked about, right? It's 4 times negative cosecant cotangent. And I mean, even that answer is okay. The only thing we could do is, notice there's no plus here. So I don't want to distribute the 4. Okay, I'm just multiplying technically like 4 things because I have 1 and then this negative and then this times this. So we could just put the negative out in front. So and that derivative, negative sine of x, and then I can move this to the front, negative 4 cosecant cotangent. All right, let's try a little harder one. All right, g of x is equal to x over 3 minus secant x. All right, so what are we going to use here? What rule do we have to use? This one we have to use quotient rule. Good. Very good. All right, so let's go ahead and just list. Our numerator is, just remember in general, we're going to use f of x to represent the numerator. That is x. And its derivative is 1. Yeah, not bad at all. So that's nice. All right, g of x, and again, remember, that's not representing this guy. This is strictly numerator, denominator, okay, just for organization purposes. That is 3 minus secant. Okay, and then its derivative.
Negative secant, well, actually, it's like 3 times negative secant x and x, or secant.
Okay, so, good point.
I didn't write negative.
So now you were right the first time, because the derivative of 3 goes away. This is maybe not the first example, right? Because we're doing the derivative.
Oh, yeah.
The derivative of secant is secant tangent, but this negative just has to come down. Do we see that? The derivative of secant is secant tangent, but that negative just has to come down. Okay, so now we're ready to go, because now this is the official derivative of the whole function. G's on the corners, right? So g of x, derivative of f, minus f of x, derivative of g, and then all over g of x squared. Yep, and don't forget the derivative of 3 goes to 0. Okay, so now it's just a matter of plugging it in. G is 3 minus secant. Derivative of f is 1. I could write it by 1. F of x is x. And then the derivative is that negative secant. Negative only because of the negative coming from the problem. Okay? And then the bottom is 3 minus secant squared. Now, do we see here? I would not put the little 2 here because I'm squaring the entire bottom. So there I don't have a choice. It has to be around parentheses. There's not much to clean up. We wouldn't have to write the 1. So we could do 3 minus secant. This is all multiplication. There's no distributing. So we could just multiply these 2 negatives and make it a positive. X, secant x, and x. All over 3 minus secant x. A lot of, I marked it the derivative. A lot of the trig ones, there's a few that can simplify, but they don't have to necessarily be pretty. Okay, what would that find us? It's not pretty. So what would that find us? That'll find a slope. If we graph this and we want slope when x is pi, or it could just be a regular number when x is 2, plug it in here, that'll give us a slope. All right, how about, okay, let's do this one. Okay, let's do f of x equals sine of x times tangent of x. And if they probably won't put like a dot or anything. So if it just says sine of x, tangent of x, that is multiplication. If like on the homework, it says something like, if you're looking like, bad writing to begin with, but if it looks like The spacing is equal. Don't worry about the spacing. This is not sine times x times tangent times x, okay? Sine by itself or any trig function by itself doesn't mean anything. Right? It means opposite over hypotenuse, but you have to know the angle measure, right? You have to, otherwise it doesn't have any value. So sine of x, sine of something has to go together, and then tangent. So sine or tangent by itself, just the word sine doesn't have any value. Okay, so what are we going to use here? This one is product, right? We're multiplying, so we got to do product. So, and again, this f of x just means the first factor, the first thing we're multiplying, okay? Remember, it's just for organization purposes. All right, derivative of sine is cosine. And then g of x is just simply representing the second factor that we're multiplying, tangent. Its derivative, tangent, secant squared. Beautiful. And that if you have to look up, I mean, that's fine. Don't ever, that one, you'll just have to take the time to look it up. Derivative of tangent is secant squared. And then it is first times the derivative of the second plus the second times the derivative of the first. Oh, not all over. I think that's right. We don't have to do it. All over is only for the quotient. Make it any longer than it is, right? All right, that is just a matter of plugging it in. First times the derivative of the second plus the second times the derivative of the first. And that's about it. We could even label that. Let's go ahead and label that the derivative. I'm not going to make you do this because we haven't spent a lot of time with trig. This problem can be simplified a little, but that answer for me is fine. But let's just talk about it. Does anyone know? This isn't going to go anywhere. How could we write tangent? Beautiful. Yep. Look at this. So this is where trig gets crazy because you never really know, can I simplify, can I not? I'm going to write this as cosine over 1. And now all of a sudden, the cosine for tangent. So now, oh, I don't use my x here. This is important. Because we're not doing sine of this guy. All right, so sine of x. I really don't need the parentheses there. Secant of x plus, and then sine. And if we wanted to, we could even factor out a sine. Cosecant squared plus 1 doesn't, cosecant squared minus 1 can actually simplify more. This is definitely a plus. So that would just say. But definitely this answer is fine, don't worry about it. But sometimes it's just kind of it's kind of neat to see how it could go down a little bit. And I mean, nowadays we have computers, but if you had to find 10 slopes, here you'd have to plug it in twice, right? Here you'd only have to plug it in once, so it would make it a little bit easier. But so with a computer nowadays, doesn't even matter. Right? Who knows? Calculus could go on the wayside because you could probably just plug everything into a calculator and it does it for you. But where would the fun be in all that, right? All right. This one really reduces, but let's at least go through the process. I don't care so much on the reducing. Okay, so let's start because this is a little bit long. All right, let's do h of x equals x to the third over cotangent x. Okay, we can do 3 more. We should be able. All right, so this one is, have we done a cotangent? No, okay, good. So I'm trying to get everything in. Okay, so this one is dividing, so we are going to do quotient rule. Okay. So f of x is x to the third, and its derivative is 3x squared. Beautiful. Roll it down, subtract 1. And you know, if you want to go right to the problem, I'll maybe show you kind of how I do that. If it doesn't take that long, you guys can write it really quick. But if you don't even want to write f of x and the derivative of f of x, just make the list. You know, the least that you can write, but makes sense to you. This is about it. But I will say, if you write things down, less chance of error, guaranteed. Okay, you frequently do and think so much. It's pretty good, but as soon as it goes on paper, then you've got it. And you don't have to think, right? You don't have to think. So write it down, then you just copy it. All right, derivative of g is the denominator. Cotangent. All right, what is its derivative? Negative, it should be cosecant, right? Yeah, I know, that's a good one. And negative is right, negative cosecant squared. You know, I was thinking, like, if this one, if for some reason you typed this, like, I would just type it like that. Otherwise, you would actually have to type it like, you are not squaring the negative. Does everyone see that? We're going to go use it anyways, but just kind of FYI, in that situation, you're not squaring the negative. All right, so now we go to the derivative. G is on the corners. We're doing, yeah, quotient. So g of x, derivative of f of x, minus f of x, derivative of g, all over g squared. Okay, and then it's just a matter of plugging it in. This is cotangent. Derivative is 3x squared. F of x is x to the third. Just be careful here, the derivative, so parenthesis, negative cosecant squared. And then all of that bottom. Well, that's not too bad. Cotangent squared. All right, so that's pretty much, I would probably move this guy to the front. 3x squared cotangent x. And what can we do here? It's just multiplication, so we could change that to a plus. Good. Now this one.
How come we can't add the like the 3 and the 2? Just because they're in like the separate. If like we're multiplying them together.
Like these guys? Yeah. Those we would have to add. Good question. Okay, those we would have to add only if the bases were the same.
Okay.
So I would say, I think if I come up, like if it was cosecant to the fourth and cosecant squared, I am making that what? Or you are making that what? Cosecant to the sixth, okay? Or the reverse. If it was just x, that would be x to the fifth, but your bases have to be the same. Is that what you're talking about? Okay, let's make sure. Yeah, that's a great question. Good. Yeah, there's nothing, I mean, I guess we could factor out an x squared. We could factor that out, but it won't cancel with anything. We can do, this does simplify some more, but I think for right now, we'll just leave it. Okay, I just want to kind of get the process. If we could come back or something, maybe we could do that later, but or should we start it real quick?
The cotangent squared x, you distributed that or like, I thought it was, the whole thing was supposed to be squared. Gx squared.
Oh, this guy down here.
Yeah.
Yes, okay, so that's a good point. So this is the same as if I wrote it as cotangent x squared. Right?
Oh, yeah, you showed that over there.
That's okay. No, that's okay. So make sure, no, always make sure that I have that. So that's the bottom, and then so you can write it either way. So yeah, we'll just leave that. If we have time, we can come back to it for simplify. It simplifies because you can change some things to sines and cosines, and things cancel. But that's okay. Like I said, we're just trying to get the process. Okay, let's try. I don't know if these two are too similar, but let's see. They're not too long. All right, f of x is equal to 3x to the 5th cosecant x. All right, so this one is back to, it's a little, yeah, it's different than what we see, but it should be okay. We're doing the product rule, okay? So this guy times this guy. And so product rule, so we'll just list, remember this f of x is literally the first factor. It has nothing to do with this function. It's just notation for first factor, second factor. All right, so that is 3x to the 5th, and its derivative is 15x.
I'm sorry, cubed. Yeah, I'm right.
So
To the 4.
subtract 1. Yep, so you're okay. You might have even right. That's actually, I think you're good at that. You roll it down, subtract 1, and go on. Okay, then g of x strictly means the second factor, the second thing we're multiplying. That is, or that we can write it. That is cosecant. Okay, now its derivative is cosecant. Good, good. Negative, and then this is the one cosecant cotangent. I don't think, yeah, this doesn't really simplify much, so it's just a matter of plugging it in, so we can go right to the derivative. First, or we could write this. If you want first times the derivative of the second plus the second times the derivative of the first. Even if you don't write it, just to hear it, that's fine. Or just write it like on the top of your paper somewhere. But it's good to hear it. Because the more times you hear it, the better. So sometimes I just do this. I'll just look, instead of looking at my list, I'll just go here and I'll say, okay, the first, and then depending on how good you are, can you just look at this and write the derivative here? Okay. It's up to you. If you like the list better, go for it. Okay. But that would be the only place, if you're really good, that was where you could kind of make a shortcut. First, and then you have to look at this, but write the derivative. So just be careful. Okay, but otherwise we can just go down there, negative cosecant, cotangent, plus, and then g of x is cosecant, and the derivative is that 15x. This we want maybe parentheses here to make sure we know where the cosecant stops. Okay? Or you could have put parentheses in. And again, we could factor out like a 3, we could factor out an x to the 4th, but it's not going to get us anywhere, so that doesn't matter. What else? Because this is negative, notice we're not doing any addition or subtraction, it's all multiplication. So I can just move that negative to the front. And then this guy, I would probably move the numbers to the front. But again, that's all more preference. In our book, just in case you're correcting like something, though on WebAssembly we don't really have that, but our book says, hey, instead of writing 2 symbols, if I put this one first, I don't have to write the plus. So yeah, I know they're
0.1 second saves.
yeah. But then by the time I rewrite it all, right, and then see how that one's minus, so then I can put that one there. But just so that you see, sometimes our book does weird things like that. You guys don't have to. Years ago, there was like an answer key, and so you would kind of flip through it, and then you'd have to recognize that. But that is on the wayside because of WebAssembly. All right. Let's do. This is just a variation of this one, so let's just make sure. Yeah, okay, 2 more. Don't let this one intimidate you. It's like the one I'm just erasing. Okay, the only difference is f of x is parenthesis 3x to the 4th plus 2x, and then times tangent of x. So, and it might take you a moment. Do you see how because there's these parentheses, that is the multiplication? Yeah, two factors, right? Factors are things you multiply, but what's in this parenthesis? You have the 2 factors.
Would that mean you still consider those 2 independent terms if you're going to derive or factors, or you treat that as 1?
You treat that as 1. Yes. Yes. Well, it depends how you. So at the beginning. Let's see if this makes sense. At the beginning, we're going to consider that 1 and tangent. All right, so this is then, do we see how that is product rule? Okay, but, okay, so now when I write f of x, remember that's just meaning the first factor. Now, what is its derivative?
Well,
Now we think of it as each one separate. Yeah, now we just go through and say, hey, that's our old stuff. We know that 12x to the 3rd, roll it down, subtract 1, and then this goes to 2. So that's the only time then where we can do each one separate. Okay, and then, all right, then g of x. G of x is the tangent, and then its derivative, the derivative of tangent is secant squared, right? And then we'll just go at it. Derivative first times the derivative of the second plus the second times the derivative of the first. And then first is just 3x to the 4th plus 2x. We'll put parentheses around that because that is a group. And then the derivative is secant squared. And then plus g of x is tangent. Sometimes I do this when I know I just have like a tangent. Well, but you can put that at the end, and then we really wouldn't even have to rewrite it. And then the derivative of f is that 12x to the 3rd plus. Something like this we could probably leave. Okay, the only thing maybe I would move is this to the front, but I don't know at that point if it's worth it. So I think we could just leave it. That's fine. All right, let's do one more. How are we doing? Okay. This one, it uses theta. The might be one on the whole that uses theta. Just more annoying because then you got to go find it on the symbol, right? All right, so cosecant divided by cosecant plus 1. As annoying as division is, it does pop out, right? As soon as you see that fraction bar, you know you're doing quotient rule, okay? Whether you like it or not, right? It's easy to identify you got the fraction, you're going to quotient rule. F of theta is not this guy now. Remember, this is just our list of numerator, denominator. So this is cosecant, and its derivative is beautiful. Negative, right? That's the negative one. And then cosecant, cotangent. Okay, so now this one, g of x, or g of theta, is the bottom. Cosecant plus 1. And what is its derivative?
Negative cosecant theta, cotangent theta.
Yeah.
So what's not
Yeah, right? That's kind of cool with it. Yeah, so she's exactly right. So we do the derivative of this guy, which just so happens to be that negative cosecant cotangent. And then she moves on and says, okay, it's 1, but the derivative of 1 goes to 0. All right. So we get some similarities here, so that means we'll probably be able to maybe do some simplifying. Let's see. All right, so derivative. Here we go, g's on the corner, g derivative of f minus f, and that puts us with the derivative of g at the end, and then all over g squared. Okay, so now let's just plug it in, and then we'll see if we can simplify. This guy is cosecant plus 1. And then the derivative is negative cosecant cotangent. Okay, then this minus, and then the f function is cosecant. And then the derivative is negative cosecant cotangent. Oh, and we can't forget, oh, this is our longest one. The bottom is cosecant squared. Yes, good. And even if that is squared, and if it's not squared, we're even more prone. How come I can't cancel this out? Or how come I can't cancel this and make this a 1?
Because you're multiplying both of it, like you're multiplying the two terms at top, not just by itself.
Okay, but if I multiply, that's perfect. That's when I do want to cancel. But I also have this, right? This minus, I would have to have cosecant plus 1 over here, too. All right, take a look. This minus says I've got this group, I have this group, and then I've got the bottom group. And so you'd have to find that in all 3 groups. I've got it here, I've got it here, but I don't have, because of that minus, I don't have it over here. Okay? But I remember that coming up in the test, kids wanted to cancel that. And I see that, and we've been doing a lot of canceling, but this little minus throws everything off. Okay, so let's.
What if the terms were reversed, or the factors on the top right there, like you didn't put it in parentheses first and the other one too? Would that make any change at all or no?
No, it wouldn't. You mean like for some reason I put this
Well,
one
actually, yeah, I
first?
forgot that negative is actually not inside the parentheses. That's a bracket.
This one.
Yeah.
Yes. Yes. Right. But this plus, we haven't seen this yet. Because of this plus, if I want to distribute this, I have to go here and I have to go here because of that plus. So what would that give us? That would give us negative cosecant times cosecant. Now that would be cosecant squared. This is just simplifying. And then times the cotangent. And then I'm taking this negative cosecant cotangent times 1. So I would have minus cosecant cotangent. Now over here, there's no distributing. Because there's no like plus sign here. This is all just multiplication. This would be like, think of this as like a -1 and another -1. We would multiply those. Everything over here is multiplication. So I'm going to multiply these two and write plus, and cosecant times cosecant is cosecant squared. And then I still have this cotangent. So here I just literally multiply the two negatives and the two cosecants, and then the cotangent is taken. Yes, we still have the bottom. But look at this. What is this guy? Negative cosecant squared cotangent. And what is this guy? Positive cosecant squared cotangent. So that all drops out. Yeah, cancels. Yep. And so then we just have negative cosecant cotangent. And then if I haven't brought it in, I'll bring in the bottom now. Cosecant plus 1. And I don't think, like the top is multiplication, so I could cancel, but the bottom is attached to addition and an exponent, so we're not canceling anything. Think of it, how do you know what to reduce? I think there's one like this on the homework, and I think WebAssign, if you don't reduce, will still give you credit. Reducing is bonus. Maybe that would even be the extra credit. There's one on the test where you can reduce. I want to make sure you can get here. So at least you've got the process. Okay, and then the rest is just kind of getting comfortable with trig and reducing. But trig will kind of come in and out. So don't feel like, oh, I'm flustered with trig. Don't worry about it. Okay. All right. We'll end there. The only thing that we have left is to prove to you like the derivative of sine is cosine, or to show you kind of where the product rule comes from. So that's still on the table. We have like 4 review days. So even if I did one every day before the review, just so that you see it, because it is kind of cool, but let's just digest this. So I'll just let you work on that. I think homework should be on WebAssign. Email me or text me if it isn't working, because I programmed a lot of these. This is the first time. Usually it was a worksheet, so I had to type it up. It's not as easy as using like Word or something like that. Where's my programmers? I'm like, oh my goodness. All right. So have a good day. We'll see you tomorrow, and give it a try. Remember the trig. You only have to remember the sine and cosine. Let me just pause it. Oh yeah,